Welcome to the deep dive. We're here to unpack the knowledge you need, maybe share a surprising fact or two, and hopefully keep you hooked along the way.
Absolutely.
So today, we're diving into AI. And, lately it feels like AI is just completely unstoppable.
It really does seem that way.
I mean, we've seen models get grandmaster ratings in chess, beat the best Go players, even crush it in competitive programming. You look at OpenAI's O3 on Codeforces getting elite rating.
Yeah, the progress in those specific areas is, well, undeniable.
Yeah.
It's genuinely remarkable stuff.
But here's where it gets interesting. There's this new research paper, it's called FormulaOne, and it kind of throws some cold water on things, reveals a more sobering reality.
Right. And what's really key here, what this paper zeroes in on, is that while AI is great at these, well, let's call them clever puzzles, these wins can actually hide a pretty big limitation. It's about the kind of reasoning depth you need for, actual real-world scientific problems or deep mathematical challenges.
Yeah, and in-depth.
Yeah. Current AI models, they tend to sort of flatline. Their performance just stalls.
Flatline.
Meaning it doesn't get better even with more data or compute. Once the problem demands a really long, complex chain of reasoning steps that all depend on each other. They just hit a wall, kind of a qualitative barrier.
Okay, so they can't string together that really intricate logic.
Exactly. They struggle to compose those complex solutions.
So our mission then for this deep dive is to really get into this FormulaOne paper.
Right.
Because it sounds like it's not just another benchmark. It's designed specifically to push AI past these puzzle-solving limits, more towards actual, research-level thinking.
That's the goal, towards genuine scientific discovery, not just competitive programming tricks.
Okay, so let's unpack what they found. Because the results sound, well, pretty dramatic. This performance cliff you mentioned.
It's incredibly stark.
Yeah.
Think about this. On the hard problems in this FormulaOne set, even when they were given a massive head start, and I mean a huge help.
What kind of help?
They were actually provided with something called a tree decomposition. It's basically a pre-analyzed map of the problem structure. It should guide the AI.
So like having a cheat sheet for the structure.
Sort of, yeah. A structural guide.
Yeah.
Even with that, top models like OpenAI's O3, Google DeepMind's Gemini 2.5 Pro, they only managed a 0.8% success rate.
0.8%. That's almost nothing.
Less than one problem solved out of 100.
Yeah.
Compare that to, say, Gemini getting 62% right on simpler problems from the same family.
Wow. So even with a map, they get completely lost on the hard stuff. Why? What's going wrong?
Well, that near total failure, even with the structural hints, points right at this core weakness in structured multi-step reasoning.
Okay.
When you dig into how they fail, you see clear patterns. One is what the paper calls premature finalization.
Meaning?
They basically jump to a conclusion too early. They commit to a path without fully exploring other options and make mistakes they can't undo.
Okay. Get stuck down a wrong path.
Exactly. Another big one is incomplete geometric reasoning. They have trouble understanding how abstract shapes or spatial relationships fit together across the whole problem. It's like they see pieces, but not the full puzzle.
Fragmented understanding.
Right. And linked to that is local to global errors. Individual steps might seem right in isolation, but they just don't add up correctly. They don't compose into a working solution for the entire problem. It shows they lack that holistic grasp.
Okay, so it's not just about getting stuck. It's about fundamentally failing to build the whole structure correctly.
Precisely.
Which brings us to the bigger picture, the implications here. You're saying these FormulaOne problems are so hard.
They really are.
That if an AI actually found a genuinely new, much faster way to solve them, it wouldn't just be neat. It could actually challenge a fundamental idea in computer science.
That's the really profound part, yes. It could potentially refute something called the strong exponential time hypothesis, or SETH.
SETH. Okay, what's the gist of that?
Very broadly, SETH suggests that for certain types of really hard computational problems, there's a fundamental speed limit. That brute force-like approaches are essentially the best we can ever hope to do. There are no clever shortcuts beyond a certain point.
So finding a super fast algorithm for these FormulaOne problems would mean SETH might be wrong.
It would certainly raise serious questions, yeah. Because these problems are believed to be among those hard cases.
That's fascinating. It puts the difficulty into perspective.
It does. And that's why this benchmark is more than just, measuring how good AI is now.
Right.
It gives us a principled, tough roadmap. a way to guide AI development towards what you might call real, open-ended scientific discovery.
Moving beyond just solving puzzles someone else set up.
Exactly. Transforming AI from just a really good competitive programmer into potentially a partner in tackling some of humanity's genuinely hard scientific and mathematical questions.
Enabling AI to actually contribute new knowledge, not just rehash or optimize what we already know.
That's the ultimate vision here, using AI to push the frontiers.
So thinking about that potential, that future where AI has this deep reasoning ability, it makes you wonder, what fundamental scientific or mathematical problem do you think AI, with that kind of power, could one day help us crack? Something for you, our listener, to ponder.